some network issue. So, okay. So we will start. Actually, here only I remember I saw here about this session. So, and how to how to right. So will be calculating the loss function. So this is what we are using here is we are using gradient descent. The thing is learning rate. So how to select this rate, learning rate? So that depends upon the adaptive learning environment. We'll be using adaptive learning rate, right? So because we need not, we should not have a small or a large learning rate. It should be a stable learning rate because that allows your network to converge smoothly and it avoids local minima. So because there may be some other minimum point, but a local minima tries to go to that point, right? After that, you will not be come downhill, right? That is your loss will be in a particular stage. Still, it can be reduced, but you will not be able to do that. That is the problem with if you have small learning rate. If you have large learning rate, then it overshoots, right? That's the problem. So we will be setting the learning rate by previous literature surveys and other things. Just like that, we will try with different rates and we will try to select. Another one is by designing an adaptive learning rate. So here, how to use an adaptive learning rate is the learning rate will not be fixed. So it can be large or small depending on the gradient, right? How large the gradient is. Based on the gradient, for each and every cycle, you will try to either have a different learning rate, and this also leads to how fast learning is happening and size of particular weights, etc. Okay, so here these are all some of the gradient descent algorithms, like sophisticated gradient descent. That is what we stochastic gradient descent. That is what we saw, and this is the TensorFlow implementation for that. And then we have Adam. These are all the adaptive. So actually, these are all the adaptive learning things, right? So we have Adam, ADA delta, ADA grade, RMS property, right? So these are all some of the learning algorithm which can be used, right, to make the learning effective, right? So with this, I thought of concluding the morning session. So any doubt? Any doubt? If you have any doubt in the morning session, you can ask me. Yeah, shall I proceed? Concluding that there is no doubt, so I'm hands-on session. So if you are with your laptop, kindly open your Gmail, and then you in another free window, you try to type Google Colab. I'm going to use Colab, and in the hands-on, we are going to see how PyTorch, right? So actually, many of them are using like Python or TensorFlow, Keras, Piano, many libraries are there. So PyTorch is also very good, and you can use it in the Google Colab also, because it is purely built on Python. It uses all the Python libraries, so we can use PyTorch in the Google Colab, right? We will see. Actually, Google Colab is nothing but it is like a Jupyter notebook, where you can all the whatever you can do with the Google notebook, the same thing can be done here, right? The only advantage here is it will whatever in Google Colab, whatever you do, that executes on the cloud, right? So your local machine will not be used. You will be using a cloud virtual machine will be allotted to you, and your entire code will be executed in the virtual machine, and whatever Colab files you are creating, that will be stored in your Gmail drive, whichever Gmail you are using and logging into Google Colab, that particular Gmail drive, all the files will be stored, right? So now we'll see the Python is one of the, actually many of them are using R also, but Python has got very good libraries. So for deep learning, Python is used, right? Now we'll see what all the libraries it has. So we have 4 deep learning libraries, and which is found to be very useful and popular. So one is Theano. Theano is one of the known Python library, and from Theano we have got TensorFlow. Nowadays TensorFlow is very very famous because of its visualizing capability. You have a very good visualizing tool which helps you to visualize this. Okay, and next what we have is we have PyTorch. PyTorch is also a library or framework which is defined by Facebook. You all know the TensorFlow is by Google, and it's also an open source, and PyTorch is by initially it was designed developed by Facebook, and now it's a open source, and PyTorch is equally good as TensorFlow, right? So if you are a researcher and if you are going to work on a small set of domain or a small domain close to domain, then you can use PyTorch, right? And next is Keras. Keras is also one of the library. Okay, right? And now we will see why we are using PyTorch, right? That we'll see. So it is a Python based scientific computing package, and the why we are using PyTorch, the simple reason for it is I told that it is designed by using Python. So Python is the base for PyTorch. So it is easy for you all those who are very good in Python. It is very easy, and Python itself is a very easy and adaptive language which you can learn easily, and it uses very very simple APIs. That's why it is easy to use, and it is very fast. PyTorch is very fast, and since it is purely developed by using Python libraries, it is very very you feel native when you use Python. And as I told earlier, it was developed by Facebook and was now it is open source, and the major advantage of PyTorch is dynamic computation graphs, right? So you can dynamically compute the graphs. That is the major advantage. And next is you have the support for CUDA, which supports massively parallel processing. So you can, if any problem or any particular task or any particular program needs a massive parallel processing or parallel computing, we can use CUDA support. We will see in the hands-on session how we can use GPU, right? CUDA is nothing but it operates on GPU. How we can use GPU to run our application, right? So now, without you losing much time, we will directly move on to PyTorch. Now I'm going to use Google Colab. So if you want to work on Google Colab, what you have to do is first you have to log into your Gmail account. Once you log in, and in the search window you type and type Google Colab and take the first link, right? If you click the first link, what you'll be getting is you'll be seeing a window created like this, right? So where you have some files, and welcome to Collaboratory is a introduction, is an index file that is available there. And then at the end, if you see, you have a new notebook. If you click a new notebook, what you will be getting is you will be getting a window like this. Here this is nothing but, one second. So whatever we have seen here, this is a, right, this is nothing but the name of the file, right? It will be untitled01. So you can just place your cursor here and change the name, and this is the extension .pynb is the extension for that file, right? And those who have worked in Jupyter notebook, they may feel that this is like a Jupyter notebook, right? So where you will be having two windows, one is for code, another one is for typing the text. And when you click the code window, you will be getting a cell like this, right? This is called as a cell, right? Where whatever commands or whatever program you want to type, that you will be typing in this cell. And then when you want to execute, just you can click here and execute, or you can go to runtime, or you can go to this file and you can run, or you can directly just by clicking the cell you can execute the code whatever you have written in this cell, right? So and with some more explanation we will move on to that. And these are all the important libraries which needs to be imported before using it. And you might have those who have worked with Python, they might have worked with the NumPy array, right? NumPy is a large dimensional array where you can store large dimensional values. It is array variable, right? And the same concept here, the PyTorch gives through tensor, right? Tensor is one of the data structure of PyTorch. So what is the difference between tensor and NumPy is, NumPy is just an array and all the mathematical operation you have to do on it. But in case of tensor, data structure wise it is a multi-dimensional array. Internally you can build relationship with the other variables also, right? That is a major advantage of tensor, right? So when you do back propagation and other things, so automatically the gradients can be calculated by using a tensor, right? So the advantage of tensor is by between different tensor variable, right? As well, and data structurally it is a large dimensional array, but structurally speaking it builds relationship with the other tensor variable. So here, and we can also bridge the tensor and the NumPy, right? So actually if you have using Python and doing all the coding, and if you want to transfer that code to PyTorch, that is easy, because all your NumPy you can convert into a tensor variable, and that is possible, and we will see in the hands-on. And when you try to transfer all the NumPy to tensor, or from tensor to NumPy, both are possible, right? You can convert a NumPy array to tensor array, or a tensor to a NumPy. When you do this, if you assign a particular array to as a NumPy and may convert that into tensor, automatically what happens is both will share the common memory. So if this is the tensor x, and if I'm assigning the NumPy array x with the torch tensor, both shares these two, because both are all same, but instead of NumPy you are just renaming, you are converting it into torch. Since you are converting it into torch, it will not create another memory space. The same memory space it will be applying the torch applications, and it will be performing. So that is called as bridge. So one of the advantage of PyTorch is you have the NumPy bridge. So if you have any Python program using NumPy, you can directly convert into PyTorch program, right? That is possible. And another salient feature of PyTorch is autograd module, right? What is autograd is, while seeing in the morning session, I told that after calculating the loss, what we have to do is we have to reduce the loss. For that, what we are using gradient descent algorithm. So how that gradient descent algorithm works, it does back propagation, it applies chain rule, and it back propagates, right? So that back propagation is done by this autograd module. So actually in back propagation, what you are doing is you are differentiating the entire loss with respect to the weights, right? Dou L by dou W, that is what we are doing, right? So we are differentiating loss with respect to weight, right? That is called as automatic differentiation, that is done by this autograd module. That also we'll see in the hands-on session, right? So here it records the operation. So what it does in autograd module, it records all the operations at whatever training data set you are giving, it records and it replay backwards backward pass also. You can perform both forward pass as well as backward pass, and it computes gradient, and then based on the negativity of the slope, it calculate the minima for the trace function, right? So now we'll see how the AutoGrad module works. So you will be defining a tensor, right? A tensor, since it is you are using PyTorch, the tensor will be called as torch.tensor, right? That is a keyword used. Torch.tensor. Actually, this is a data structure is defined with which can store multi-dimensional array value, and it is one of the central package. So if you are defining a tensor and if you want to perform AutoGrad function on the tensor, then you need to define along with the variable value an attribute requires grad, and this should be made equal to true, right? We will just, you remember at this point. So you have to define attribute requires grad as true. This has to be defined along with the tensor, right? We'll see with an example, you will understand. So when you define this one, what happens is it tracks all the operations, whatever operations you are performing, all the forward pass as well as the backward pass operations will be recorded, right? And once it is done, after computing all the forward pass, after tracking all the forward pass operations, what you will do is you will be calling backward pass, right? So after performing backward pass, you will be calculating gradient. How to calculate the gradient is you will be calling x dot grad or grad dot loss dot grad, something you will be using, and you will be calculating the gradient. Once calculating the gradient, this gradient is stored in the gradient variable. For example, you will be calculating two gradients. One is a weight gradient, another one is bias gradient, and these two are stored there. And once gradient is stored, then you need to adjust the weight, right? So while adjusting the weight, you need not keep the forward pass. The forward pass has to be eliminated, right? So for that, we have to stop tracking the history. So for that, we can use two things. One is either you will be using call.detach along with the tensor variable, or you will be using torch.nograd. Mostly we'll be using torch.nograd, right? So actually this you may not be familiar if you are not working with PyTorch, right? We'll see the example, then you will understand, right? So with this, I stop here with my presentation. I will go to the collab, and we will see how to define a tensor, what all the operations that is performed on the tensor, all these things, and then we will also see what is AutoGrad function, how the derivations are done, right? All this we will see. Once again, I will share my collab file. And if you want, I will share this collab file to your coordinator at the end of this session, so that you can practice at home or you can see out. So this is I am not going to type any code today because it will take time. So I have did this before itself for demonstration. Just I will go through the code, right, and I will share you this so that you can later on you can practice, right? So is it visible? My screen is visible. Hope it is visible. It is readable, no? Readable, no? Or you want me to increase the size?
Increase the size, madam, little bit.
You want me to increase the size? One second. Is it okay, ma'am? Is it okay now?
Yes, madam.
Yeah, font size is visible,
Yes,
right?
Okay.
Nah, yeah. Okay. So here, this is the collab file. Actually, I have given 250% increase in the size because the font should be visible to all the participants, right? So as I told, here you can see the name. I have given the name of this as example 01. right? If I want, I can just rename, just a click and I can change the name here, right? That is easy. And here, these are all the menus available. And here you can see file, and these are all the things, right? So you can create a new notebook or the existing notebook, whichever stored in your drive that you can open. And here, one of the important thing here is in edit, if you go and scroll back, scroll down, you can see notebook setting. So in the notebook setting, if you click, right, you have hardware accelerator, right? So hardware accelerator, this is what the tool, right? So if you click, you can see three things. One is a none, GPU and CPU. So that's what I told. If you want to increase the speed of the computation, you can use this GPU. TPU is Terra Processing Unit that we will not be using. This is defined by Google for their purpose. I have not used it. I don't know whether this can be applied or not. So GPU we can use. If I am just giving none, then it will just execute the whatever operations we are doing, that will be executed on the CPU but not on the GPU. Either here whatever we are doing, that will be executed on the virtual machine, not in your local machine, right? So this is, so I have selected none here, right? Hope you remember. I have selected none, so I'm going to execute at present the code on the CPU, right? And here you can see connect. So this has to be this is not yet connected, and this is not connected, just I have opened the file. So if I want to get executed, this needs to be get connected. So I am importing the basic things, right? So import torch library, import numpy, and then import matplotlib. So all these you might be using, right? These two you might be using with your Python, and this is the new one, right? So I'm just if I just click on, you can see this is circling. So that means that I am running the code, right? And simultaneously you see here you can see it is telling connecting. So initializing. So what it connecting means, it is connected to, so here you can see once initializing and it's get connected, you can see the RAM and the disk allocation, right? So virtually this much RAM, right? And this much disk space is allocated for you. So you were connected to Python 3 Google Notebook, and then your RAM allocation is 0.7 GB to 12.72 GB, which is sufficient for you. And then your disk allocation is up to 1.7 GB, right? That is what is allocated to you, right? And then now we'll move on. So this is how you will be defining a tensor, right? So how to define a tensor? Now I am defining X as a tensor. So I will be defining like this, torch dot zero. So what I am defining is X as a tensor variable, and I'm initializing all the values to 0. I told what is a tensor? Tensor is nothing but a dimensional array, multi-dimensional array. Here I am defining 2 dimensions, right? 3, 2. 3, 2 and all values 1, right? So when I run this code, print X, so it is printing like this, right? Tensor and zeros. I'm defining X as a tensor, and it has 2 rows, right? Sorry, 3 rows and 2 columns, right? That is what I have defined, and all values are initialized to 0, right? So this is what it does, right? And these are all the sum of the, here I am defining X as zeros, and X is a tensor of 3 cross 2, and I'm initializing all ones. I can also initialize to random value, right? This is also possible. So after typing this code, I'm just executing this. This is already executed just for. So here you can see it is printing first X, first print X, it prints all 0. Second print X, it all prints 1, and third print X, it all prints random value, right? Random value. So I can this tells that I can define a tensor, and I can initialize the values of the tensor with either zeros or all ones or random values, right? All these threes are possible. Or I am not giving anything, then it will just define a tensor and it just allocates some memory without initializing. That is also possible. So here if I'm giving x is equal to torch dot empty 3 cross 2, so I am not defining anything. I am not defining the values of tensor as ones, zeros or random. Just I am giving empty. So what you will be getting is you will be getting like this, right? So what it does is it allocates some memory space, but the tensor is not initialized. Sorry. So here so this is what has happened. So here it is initializing already some values. This is NaN is nothing but non-numeric value. Some numeric value is allocated in this memory. So this is how you can initialize. So I can also initialize like this, right? Y is equal to torch dot zeros like x, right? So what happens is y is dimension is defined by the x, right? Whatever dimension I have given 3 cross 2 as a dimension, so it's giving here 3 cross 2 as a dimension. So the same dimension y you can define y also, right? So and you are initializing all the values to 0. That is what it's print, right? Hope it's clear. Hope it's clear. And you can also initialize by using linear space, right? So for example, I want to initialize my tensor with 5 values, 0 to 1 and step 5. Then how this will be is this is a single dimensional single dimension matrix, or sorry, single dimension array, where you will be having only one row and the values start with 0, 0.025, 0.5, 0.75, 0.1. So that is also possible. So that is what this is defining, right? So like this we can do, right? So this is how, and we can also initialize the value, right? If I'm giving like this, it automatically initialize, right? The first one is considered to be the first row. And how to initialize this? By using same like your Python, where you will be using the list, right? This is how you will be defining the same thing. You will be how to, however you define the list, the same way you will be defining, and each row within a separate square separated by comma, and everything put in a square bracket, right? So and this, that's all about initializing the tensor, right? So far no doubt, I hope. Now we'll move on to slicing, right? This is one of the operations performed on the tensor, right? Slicing operation. So slicing is if you have a very big tensor or multi-dimensional array, and if you want to do only a processing on a particular indexes, then you will be using the slicing operator. For example, I want to take only, I have defined a matrix of n cross n, and I want only the fifth row and the seventh column variable, and I want to, or I need only the fifth column, and I need to perform some operation on that, right? So for that we will be using the slicing, right? So how to slice is, this is actually to know the size of x. X so far we have defined it as 3 cross 2. So when I run this print x dot size, then what it will be printing is this prints torch dot size, informing that x is a tensor variable, right? And we are using PyTorch. So this is a tensor variable, and this size is 3 rows and 2 columns, 3 cross 2 matrix, right? And if I am printing 0 comma, if I am giving like this 0 comma colon, what will be my output? So this is my tensor, right? 1, 2, 3, 4, 5, 6, right? For this, what will be the output? Can anyone guess and tell me? If I'm applying 0, so what it will do? Whether it will take the first row or first column? You can give it in the chat box, or you can unmute and give your answer. Guys, why no answer? How many of you know Python? Am I audible?
Yes, yes, you're audible.
By why no answer? Okay. So actually, if I'm giving like this, what I told, yeah. So 0, what I am doing is I am trying to size the first dimensional thing, right? That is the first row, right? So if I do like this, if I give and execute this code, what I'll be getting is I'll be getting the first row, right? That is first row is 1 comma 2. That is what I am getting here, right? And when it give like this, so what it will do is this tries to print x within bracket colon comma 1. What I am doing is I am trying to slice the column. Which column? The last column, right? So actually how we will be indexing is this first row is called as row 0, row 1, row 2, and this first column is row because I cannot use pointer here because it is a tool. So just follow my cursor, right? So here this is the column 1 and this is column 2, right? So sorry, this is column 0, column 2. So what I have given here is I have given colon comma 1. So my intention is to take this column, right? The last column. So what the output should be 2, 4, 6, right? That is what I'm getting here. So 2, 4, 6, right? Okay. Okay. So here again, if I'm giving 1 cross 1 and print, I'm going to, here this slices a single variable. So 1 cross 1 means what value will be getting? This is our tensor. This is our matrix x tensor. So here this is row first column, second column. Sorry, this is 0th column, first row, 0th row, 0th row, first row, second row. So if I'm giving 1 comma 1, what it has to print is, so this is 0, this is 1, and this is 0, this is 1. So 4, it should print 4, right? So we'll see whether it is printing 4. So 1 comma 1, print y. So for print y, it is printing tensor 4. Right? I want tensor 4. It is telling that it is the, it gives a value of that particular tensor. But if I want to print the value of that particular index or particular 1 comma 1, I want to just print the value, then I will be giving y dot item. Y dot item tries to print the value. This prints the array value, right? So this prints the array, this prints the item value, right? Hope it's clear. So again, this is for you 1 colon, comma colon. It's second row. First row is 1 comma 2. Second row is 3, 4, right? And this is again 2 comma 1. Here, 2 comma 1 means in this I'm going to take which one? So where is it? Sorry, 2 comma 1. So 0, 1, 2. This is the second row, and 0, 1. 2 comma 1 is 6, right? So 6 has to be printed, right? Tensor 6, and if I am printing item, it will be printing value 6, right? So that's all about slicing. So hope it's clear. Now we'll see reshaping the tensor, and I'm going a little bit fast because it's time is very less here. Print x y is equal to x dot view. Actually, you want to work with me, I will be going a little bit slow, or I just listen. Afterwards, I share this file so that you can work at your home. That is which option we want to follow.
We want to listen, ma'am.
Yeah, you please listen, and then afterwards I will share this so that you can just go through and learn the basics, fundamentals of the PyTorch, right? So here, this is how the reshaping tensor. So here I am printing x, y is equal to x dot view 2 comma 3. If I am giving like this, then so actually what I am doing is I am x is already x is a tensor which is defined. I have not changed any thing in the tensor. So whatever x is defined, 1, 2, 3, 4, that is 3 cross 2 matrix, that is already, that is there, right? So I'm not disturbing. So what I'm doing here is I'm trying to reshape it. I'm giving y is equal to x dot view of 2 comma 3 and print y, right? So what it will do is I am initializing y, right? And I am whatever here, this is 3 cross 2 matrix. This 3 cross 2 I am converting into 2 cross 3, and that I am storing in y and I am printing y. So I am printing both x, and after conversion I am printing y. So the output when I execute, I am not executing this because already it is pre-executed. If I execute, it will take time. So I am using the pre-executed output here, because for this it is not an issue. But some big program, if I execute again, it will take much time. So here, this is this print x, it prints the already x value, and here what I am doing is I am converting, that is 3 cross 2 matrix, I am converting into 2 cross 3, I am storing it as a y tensor. So if I give print y, it will be printing like this. So 1, 2, 3, these first 3 values become the first row, and last 3 values becomes the last row, right? So that is also possible. That is called reshaping the tensor, right? That is also possible in the tensor, right? So if I'm giving x dot view 6 comma minus 1, so actually x dot, so this is 5 6, what I'm giving is x dot y is equal to x dot view 6 comma minus 1, print y. So can anyone tell me what it will be printing? Or you can leave it in the chat box also. What output it will give? So the last dimension I have given as -1. So it means that, so actually you all know that first value 6 is for rows, and this is the second one, -1 is for column. Since I am giving -1, what it means? What it means? Single column, right? Single column. So actually -1 is nothing but it is single column. You can give 1 also here for this particular thing. So here if I am printing y, what I am getting is all this will be as a 6 rows, right? 1, 2, 3, 4, 5, 6 as a single. So this is what I will be getting. So single column, 6 rows, right? Each row 1 value, right? So that's all about a view. Now we'll see tensor operations, how we can perform the arithmetic operations on the tensor, right? So here I am defining two tensor x and y, both of type of same size, 3 cross 2 3. The shape of both the tensor as 3 by 2 matrices, and this if you perform, if I give z is equal to x plus y, it perform tuple addition, right? You know what is tuple addition if you have learnt Python. So tuple addition is nothing but the first row, first column value will be added with the first row, first column value of y matrix, right? Same way, second row, first value will be added with second row, first value. That's why if you are going to perform addition between two tensors, both the tensors should be of same dimension. If the dimension is not the same, then you cannot perform the addition operation. That has to be checked, right? So if I'm giving like this, so what I'm giving is I'm defining x as all ones, y as all ones. Now all ones, 3 cross 2 dimension all ones, 3 cross 2 dimension all ones. If we add same or z output, if you print z, what you will be getting is you will be getting white. So here, here again I am doing tuple addition, sorry, subtraction, x minus y, and then print z. What it will print? It will print all zeros. 3 cross 2 matrix of all 0 values. If I multiply, it will be giving all ones, right? All ones. So now we'll see how it is printing. So here, this is addition. This is subtraction output. This is the multiplication output. output, right? Hope it's clear. So arithmetic operations can be performed. You can perform tuple operation also, right? So tuple addition, tuple multiplication, tuple subtraction, all these three are possible. And you can also do like this. If I have another tensor z and I have two tensor y and x, so what I'm doing is I'm adding the value of x to y and storing it in the z, right? Adding x with y and then storing it in the z, right? And I'm printing z and y. So actually here I'm not initializing any value to x and y. So what it will take is it will take this previous value, so where all the values are ones, right? So when I perform add y dot add, what it will do is it will, one second, I will execute this code and I will do this because I have changed the values there. So here you can see it's getting. Now if I'm doing this, so it's 6, no, that is for some other value. So now I'm executing this, right? Z is equal to y dot add of x. So what happens is 1 is all 3 cross 2 1 is added with all 3 cross 1 and that is stored as Z here. So Z value will be all 2's and y value will be all 1, right? So now I execute. So you can see Z value is all 3 cross 2 2's and all y value is all 3 cross 2 1's, right? So this is, so again if I'm doing this, what I'll be getting is I'll be getting the same value because the y and z value, x value, y value are not changed. Since x value and y value are not changed, I will be getting the same. How many times I execute this, I will be getting the same output, right? And another one is you have one more add. This is a add where, so you can see the difference here, just add of x, and here this is y dot add underscore of x, right? So what this underscore will do is this underscore will add x with y and stores the value to z, as well as the added value will be updated into y also, y vector also, right? So it adds x vector with y vector and it stores the result to z as well as to y, right? That's what it will do. So here I am printing both z and y. Now I execute the code. So here some value. So I'm executing this. So what you should get, I'm not showing the output. What you should get, you should get z value all twos and y value should also be all twos. This should be the output for both z and y, right? So you can see that. This is the output for both score x. It is adding x with y and it is also storing it to z, as well as a copy is made to y also, right? So again, if I now execute, what will be the output? I'm not showing the output. Just a guess what will be the output if I'm again executing. Any guess? Sorry, some of them have given output that I have not seen. Okay. So here, what happens? What happens? What is your guess? So actually, this is what we saw previously. Both the values were 2, right? So when I try to add, now the value of y is 2. When I add with x, what happens? X is all 1, this is all 2. 2 plus 1, it will 3. 3 will be stored in y as well as 3 will be stored in the z, right? So that's what happened. 3 is stored in x as well as. So again, now I compute, what you will be getting is you will be getting. So here this will not change the value. If you execute this how many times, it will not change. Whatever the value of x and y, it will be the same. But here, since your y value is changing accordingly each and every time, the value of z and y will be changing, right? So with that, this is some of the operations. And now we'll see NumPy and PyTorch, how it acts as a bridge, right? We already saw, right? I told that NumPy array can be converted to an PyTorch tensor, and the tensor can be reverted back as a NumPy, right? So that is possible. So here, this is a piece of code. So just I will explain what I'm trying to do in this piece of code. So XMP, so I'm defining a NumPy array where x dot NumPy. So already I have defined, is it not? And NumPy as NP I have defined. I have imported that. So here I'm using x underscore NP is equal to x dot NumPy, right? So I'm x is a NumPy. Okay, and I'm printing. So actually what I'm doing is I'm xnp is a variable, right? I am initializing that with x dot NumPy. So actually x is a array and this is a NumPy array. So that NumPy array I am initializing to x, right? Actually xnp is nothing but a torture tensor, right? So this is a tensor. To that I am assigning a NumPy and I am printing x, type of x. What is x? Sorry. Okay, actually this is x, right? So here x I have defined. Sorry, I'm taking from the previous. Sorry, a little bit confused. So here x I am defining as 3 cross 2 matrix, right? So what it is happening here is what I'm trying to do here is I am xnp. This is a what? This is a xnp is a NumPy variable, and what I'm doing is I'm converting x into NumPy, right? So I am converting this into right? And sorry, I'm now applying bridge operator, right? So I'm converting x tensor into NumPy, that is x dot NumPy of. So tensor is converted to NumPy and stored in this. What I'm doing is I'm printing x should be type of x. So what is x? X should be a tensor, right? A type of xnp, I'm converting the tensor into NumPy. So xnp should be a NumPy variable, and I am printing x and I am printing xnp. So actually what is the value of x? X is nothing but here I am defined x as a 3 cross 2 matrix, and the value of x is all ones. X value is not changed, right? I am not changing the x values anywhere in this so far, right? So what I'll be having is I'll be having 3 cross 2 matrix of all ones, and that I am converting into a NumPy and storing in a NumPy variable. Here I am printing the type of x variable. X is a tensor variable and xnp is a NumPy variable. So I am printing the type and x value of x as well as value of xmp. So when I run this code, what I'll be getting like this. So here you can see type x. This is type printing that its type is stars dot tensor, and here this is printing that this type np type is numpy dot nd array, and here that x value I am printing the value of x. So it is a tensor of all ones, and this is a NumPy array of all ones, right? So you can see the difference, right? So you can see the difference between tensor and NumPy. So x is a tensor, and I am converting x into a NumPy by using the NumPy function, right? This converts x into NumPy. Hope it's clear, right? And I'm storing into a NumPy variable, and then I'm printing the type of both. This is just to show you what is x and what is xnp. So it prints that the type of x is nothing but torch dot tensor, and this xnp is numpy dot nd array, and the values, how the values, right? So if it is a tensor, it prints like this. If it is a numpy array, it is prints as an array, right? Hope it's clear. Now we'll all once again see how this, so we saw how a tensor can be converted to NumPy. Same way how a NumPy can be converted into tensor, right? That is also that the numpy to tensor, that will also see. So here I'm defining a I'm defining it as numpy array. So previously in the initially I have given that import numpy as np. So if I'm giving a is equal to np dot ones, so a is defined as what? Defined as a one dimensional numpy array with all the values equal to 1, right? All the values equal to 1. So I'm printing a, and then I'm initializing another variable a pt. The pt is nothing but pytorch. So a pt is nothing but I'm trying to define here it as a tensor, torch tensor. So I'm giving like this, torch dot from underscore numpy a, right? So I'm converting numpy a from numpy a to torch, right? So this function, right? So here you can see numpy, this converts tensor to numpy. This function converts a torch, sorry, a numpy variable to a torch variable, and I'm printing both the type of a and apt and print apt. So when I execute this piece of code, what I'm getting is I'm getting this, right? So a is equal to all ones, right? All ones. It is a numpy array, so you can see single dimensional array of all one value, and then I'm initializing apt. From numpy I'm converting it into a torch sensor. So when I print the type of a is nothing but numpy array. So np numpy, that is the type it's printing. And when I type the apt is nothing but torch tensor, and I am printing the value of, so tensor all ones, and here it is giving the type, right? Torch dot float 64. Float 64, or you can give int or float 64. Float 64 means it is a floating point number. That is what it has defined, right? Hope it's clear. Now we'll see how dot add a is equal a comma 1 comma out is equal to a. So this is how you'll be performing adding. So already I had defined an a numpy array where all the values, it is a 1 cross 5 matrix, or 5 cross 1 with 5 column and 1 row, right? And I'm adding 1 and I'm storing the value in the a itself, right? So I'm not defining anything. I'm not converting that value to a torch tensor or anything. So I'm just adding 1 to numpy array, and then I'm printing the numpy, and I am also printing the torch tensor, right? So this is apt is a torch which I am initializing from numpy, right? So when I try to print, what happens is it is printing. You can see the both the values to be. So what this means? This means that both A and APT is sharing the same location, right? So that's what I'm trying to explain. So if you define a tensor from the numpy, or if you define a numpy from a tensor, both shares the same memory space. It will not share different memory space. So that's why it's called numpy bridge. Excuse me. Okay, hope it's clear. Is it clear?
Yes, yes, it is clear. No issue.
Yeah. Thank you. Thanks. Only one person is responding, so thanks for that. So now we'll see. Now, actually, I'm with that. I explained you how to initialize a tensor, how to perform the operations like slicing, reshaping, all these operations, how to perform on a tensor, and we also see how to bridge a tensor with the numpy. Right now, we'll see what is the advantage of using tensor, right? So why we are moving to tensor? What is the need? You have all the facility with the numpy itself. If I'm using Python, Python has numpy, all the facility in numpy I have. What is the need to go for torch? You may be asking me that one. Why PyTorch? Why tensor? Why all these things? So why we are using, or why tensor is used is the computation will be fast, right? So to explain how the computation is fast, I have written this piece of code. where this double slash time, right? So you hope it is clear here. This double slash time, this tells that time execution, right? So what is the execution time taken for this? So it prints a time at the end of the code, right? So even though I'm not giving any print statement, it prints something, right? So here what I'm doing is I'm defining an loop with a epoch of 5, right? So 5 times the loop will be executed. What I'm doing is I'm defining an NP array, numpy array, and initializing that array with the random values, right? I'm not defining any value, so I'm defining. So how to define random values is there for torch you will be just using rand, but here you have to use random.rand and a 5 cross 5 matrix. So A is a 5 cross 5 matrix with a 5 random value, and B is a 5 cross 5 matrix with a random value. That is, A has 25 random value. 5 cross 5 means 25 random values. B has 25 random values, and when you add together, C will be having a 5 cross 5 matrix with 25 random values, right? So, sorry, 25 added values that you will be having in C. So when I run this code, I'm running this. So here I'm not printing A, B, C, anything. So I'm just giving slash slash time. So this, when I execute, this prints the time taken. So you can see the execution time, CPU time taken is 324 microseconds, system 70 microsecond. Total this one, and the wall time it's given 315 microsecond, right? So the same piece of code I'm going to define with tensor, right? So the same thing, you are using np.random.rand. Here you are using torch.random. I'm defining two A and B with 5 cross 5. Same thing. Same thing. Nothing I am changing. Nothing I am changing. Array I'm using torch. Tensor, right? I'm using tensor, right? So when I execute this piece of code, you can see it is, sorry, something went wrong. So sometimes it happens like that. Now it's reducing to 207 microsecond, right? So you can see when you use numpy, sorry, this one, see for some random values it may, because I'm not using any constant value. If it's random value, because of the random value, the time is changing. So here it is 315 microsecond, right? So still this can be reduced, right? If one thing, and this is a very, very simple 5 cross 5 matrix addition we are doing. But when you take you can appreciate when you take a very, very processing like a neural network with 100 weights and something like that, right? So in that case you can appreciate the difference when you use tensor and numpy, right? So here we are taking this another piece of code where I'm using a np, the A, B, C, both all three are random, sorry, all three are numpy variable, A and B, it's a random. And so when I execute this, the time taken is 20.4 second, right? This is 20.4 second. The same using what, torch, and then the same operation I'm performing. And if you check the time, the time is 24.5 seconds, right? So here it is. I will execute and see. So you can see it's taking time. While executing, you can see here RAM disk. it's 20.5. I execute this. $22.8, right? Still it's lost. So I will give instead of rand, I'll check with ones. Three dot ones. Giving type error, so something.
Square bracket, ma'am?
Not square bracket. Is the same. Actually, for this it is this one only. So here we are using only for numpy array. It is this one only. But we'll see what is the problem. Okay. So we'll cross check this later, right? So I don't want to spend time. Actually, if you, yeah, I will rectify it and share the file. You can appreciate the okay. So I'm leaving it. Right, with this I'm stopping, and we will see so far whatever we used is we used CPU. Right, now we'll see how CUDA support is given, how how GPU can be used, right? So what and you all know that I have disabled and I have given none. So when I print torch.cuda.device count, so how many? CUDA is nothing but, parallel processing device, that is your GPU. So how many GPU device is available? If I am trying to print that, it is printing 0, right? So I'm going to edit, and in the notebook setting, I'm making this as GPU, right? Hardware accelerator, I'm converting it into GPU, and I'm saving. So now I am so now actually I have now converted to GPU. So what I should do is I should execute, I should initialize all the thing, right? So I am going back and initializing. So without initialization, it will not work. So I'm initializing. So once initialization is done, now again I'm coming back. So need not, I'm not bothered about the other code. If you want, you can execute, but it is not needed because all are not independent. All are independent. They are not dependent on each other, right? So here, what happens is, once again, something is happening. Automatic saving failed. Remotely or in another tab. Okay. So what I'm doing now, if so now if I'm printing this one, you can see one. So since I have changed the hardware accelerator to GPU, now this has become one. Okay. Now we'll see. Now you can check the type of the device also, right? So I can give a torch.cuda.device of 0. So actually here, this is a count. Count is giving 1. So always in Python, your index starts with 0, right? Index starts with 0. That is, if you have an 2 cross 2 matrices, the first row is 0th row, second row is first row, and the first column is 0th column, second column is the first column. So always the indices start with 0, right? The same thing if I want to print the device, type of the device, right? I have been allotted with the GPU device, right? So if I want to print, I will be giving torch.cuda.device of 0. So it prints that, and then it prints cod.cuda.get device name of 0. So actually this will give the identification number. This again instruction will give you the type of the number. So when I execute, so here this is the previously executed. Now I am using different, right? So previously this is the identification number for that particular device, and this one, right, with the Tesla P16 GB, right? So this is this one, right? So need not be the same device is allocated every time, because it is allocated in the cloud, right? Now if we execute, you can see it's different, right? So this is the identification, and here Tesla K80, this is the GPU device attached to my program is now executing in this GPU start device. So here this is very important, right? So when you use GPU, right, or if when you are going to execute the tensor on GPU, then all the tensor should GPU, right? For that we have to initialize 0, where this CUDA 0 is equal to torch.device CUDA will be moved on. So each and every tensor in any, you can define T1, T2 or anything you can define, and that has to be applied here, right? So here if I see this code now, this piece of code, A is equal to torch.1 3, 2, device is equal to CUDA 0, B is equal to torch.1 3, 2, device is equal to CUDA 0. So device, once I define this device, then want to execute your program on the GPU, wherever you have tensor variable, all the tensor variable you should define the device is equal to this variable, right? So see, you can here previously we will not be using that. We are not, because we are executing on the CPU. Since we are going to execute on GPU, that has to be explicitly informed in all the tensor, right? Only then it will be executed on the GPU, otherwise it will not be executed, right? So here this is how. So here once you print, it will print, and it will also define the device is equal to CUDA 0, informing that these tensor were executed on the the GPUs, right? So now we'll take the same piece of code, and here we'll calculate the time taken. So if you are using this is a numpy array, so your time taken is 21.8 seconds. When you use CPU, sorry, the with tensor without CUDA device, right? Tensor without CUDA, I'm executing only on CPU. So actually, I'm not defining the CUDA device here. So it will be on the CPU. In that case, the time is 8 device, that is your GPU. If you can see, it is 3.1 millisecond, right? So you can appreciate the difference, right, in the timing, right? So the numpy array, it takes 21.8 seconds. When you use tensor, there is no much difference. It is 8.6 second. But when you use the same tensor and use what millisecond, which is very less compared to about two values, right? So this is for a simple calculation of addition, right? If you have a matrix multiplication of value, So this is performing matrix I'm not executing because all the same thing I'm executing on for 88 milliseconds. Same applying tensor, it is taking 488. When I execute per GPU, it takes only, right? So you can see that you can see how PyTorch tensor is effective. If you have any doubt, I will clarify and move on to the next.
Ma'am, I have two doubts.
No doubt?
I have two doubts.
Yeah, Amma.
Yeah.
Yes.
The first one is the comparison when we do between NumPy and Tensor. Is it only the CPU's processing speed the difference, or we have any functional differences also?
No. You have functional difference also, right? As I told earlier, tensor, it is not alone a n-dimensional matrix or n-dimensional array. You can do, that is what I am going to tell now. The tensor has the capability to bookkeep the information, right? That is, you want to build relationship between multiple tensor, that is possible, right? That is possible. That is, if you can do the back propagation, that is, you can calculate gradient by using that, right? That is the advantage of tensor variable, which is not there in the NumPy, right? Okay, I will explain that now, you will understand.
Okay, ma'am. With respect to memory, do we have any difference? The memory saving capacity between NumPy and Tensor? With respect to saving memory or memory optimization?
Memory, I don't think that there will be much difference because I have not worked in that aspect. Maybe I will check and then let you know, ma, because I don't want to give a wrong information. So far I have not thought of that because so far we were using some cloud to store, so memory is not the concern that time. So I'll cross check and let you know. Nice query, but I have not thought of it. I will check and let you know.
Thank you, ma'am. Ma'am, last question. In NumPy, can we use GPU? Because when you were executing, I observed first time, second time, the time taken for processing was more, even in Torch. When you executed for the third
Yeah.
time, it got reduced.
Yes. I will tell you why that is, because I have initialized the tensor with the random values, right? So since I have given random, each and every time the value changes, right? It is not going to be the same value. So that's why I tried to explain with all ones, but somewhere it is problem. So it is telling that I cannot change the
Hello, ma'am, your voice is disconnected.
And your voice is breaking. Actually,
Ma'am,
you are
you're
not
not
audible.
audible, ma'am.
Hello.
Hello? Ma'am, it got disconnected, your voice.
Value and check, then we can appreciate the efficiency. Okay, ma?
Okay, ma'am. Thank you.
Okay, thank you. Thank you, very good. I'm happy that you are attentive and interactive. So now we'll move on to the next one. Next is AutoGrad. AutoGrad is, I told, it's one of the important features of PyTorch. So what AutoGrad does is it helps you to calculate the gradient by performing automatic differentiation. That is the advantage of using Torch, right? So you need not use a separate function to calculate, or need not do some different operations, right? A single operation like back propagate will backward pass will do all the gradient calculation. So that is the advantage of using this one, right? Torch. So here it imports a torch, import same thing, whatever that has to be imported. So here it's getting connected. Wait, we'll wait for some time. Yeah, it's done. So here, what I am trying to do is I'm trying to perform AutoGrade, that is automatic differentiation. So for that, what I'm doing is I'm defining X variable, and where X is a 2 cross 2 matrix with all the values as 1, right? So when I print X, it will be like this 1 1 1 1, right? Now again I'm sorry, this is not. So here this is what I'm taking. So I'm taking X is equal to torch dot 1 3 cross 2, and here I'm giving requires grad is equal to 2, right? So you asked me a question whether NumPy array and torch are same, one and the same. I told that a torch tensor you can use it, and you can build relationship between tensor, right? So actually, if I'm not giving, if I'm just defining X is equal to torch dot 1 2 cross 2, it is same as your NumPy, right? So nothing, you cannot perform any other operations. It's just like your NumPy array. But when I define requires grad is equal to true, when I define this variable as true, then what happens is X is defined as a tensor, and X also performs some bookkeeping, right? So I will tell what is bookkeeping when I go through this hands-on session, right? So it also it also does bookkeeping where you can perform the differentiation, right? So that is the advantage of tensor, right? So here I'm defining X as a 3 cross 2 tensor, and I'm defining require grad is equal to true, right? I can give true or false. So I need gradient to be set to true, because I am going to do some back propagation, right? For that I'm making it as true, and then I'm printing. So when I print X, so you can see the difference between these two statements, right? So these two piece of code. Here I'm not defining this one. Here I'm defining requires grade. So when I print this, it will print all ones, and then here it prints required grade is equal to true. It tells that this gradient is set, right? For this X tensor, gradient is set as true, right? And this is just X I'm defining here, and now I'm going to perform some operation Y with respect to X. So I'm defining Y as a function with respect to X, where I'm adding X with plus 5. So what it does tuple addition. So what do you mean by tuple addition? With all ones, right? So 3 rows, 2 column, this 5 will be added. So what I'll be getting when I execute this, and when I try to print Y, I'll be getting all 6, right? So it will be printing 3 cross 2 matrix with the value all 6. That is what I'm doing. Y is equal to X plus 5, and then print Y, right? So here you see it's printing y value. And see, I'm not defining gradient for y. I'm not defining y anywhere. Y I have not defined, right? I have just defined x with gradient is equal to true, and I'm doing a function y with respect to x, where I'm adding 5, just a simple addition I'm doing, and then I'm storing that in y. So when I print this y, so automatically, so just I'm printing y, so it's printing all 6 with grad function is equal to, so what it is doing, it is keeping some bookkeeping, right? So it add backward. So we don't know what is this, just it is already done by the your compiler itself, right? So it gives that add backward. This is a gradient set here, right? Gradient function is set. So this is called as bookkeeping. Something is book kept here, right? So the gradient is a book kept here, right? That is, even though I'm not doing anything, I'm not defining the gradient for y. Since I'm defining y with respect to x, it is set, right? So now again, I'm going to write one more function above that y. Actually, y I have defined as the function of x. Now I'm defining one more function z, and it with respect to y. And then I'm adding 1. So that is y square plus 1. So y is what? All 6. So what I'm doing is y square plus 1 and then print y. So when I do y square plus 6, what it will do is 6 square. 6 square is 36. 36 plus 1 is 7. And when I print z, what it will print is, it will print all 37 value. Again, grad function is equal. So I am not define any grad, but since it is again a function on y, it is bookkeeping this, right? Hope it is clear now. And now what I'm doing is, and I'm writing one more function. So here I have defined x, I have defined y with respect to x, and z with respect to y, right? So that is, I'm following some chain rule. And now I'm doing t is equal to torch dot sum of z. So what I'm doing, I'm just summing all the values of z. T is equal to torch dot sum of z and print t, right? When I do this, what happens is, it adds all 37, that is 37 into 6 is 222, and then that will be printed, right? So now I'm just will see what it is printing. You can see tens are all 2, that is all 37 into 6 it performed, that is 222. And here you can see the grad function. So far the grad function were add backward. So here what I'm doing is, I'm calling internal sum function on the tensor. So you can see sum backward. So this is what is done, right? So it is bookkeeping. It is keep on having the bookkeep value, right? So now what I'm doing is, now I'm doing t dot backward. So till now I have done a forward pass, right? So I defined x with all ones, z with respect to y, that is z is sorry, y with respect to x, that is y is equal to x plus 5, and then z with respect to y, and then I have found the total sum. And what I'm doing is, I'm backward passing, right? T dot backward, right? T is nothing but sum of all the values of z, right? And backward pass. Now after running this piece of code, so sorry, here it will get error because I have not executed this. One second. Once again, I will close this and open again. Something is problem with my collab file. So actually, when I did when here I'm doing back propagated, right? And t dot back propagate, I don't, nothing will happens, right? Just if I execute, nothing happens. Something internally happens, and then when I try to print x dot grad, what is expected to be printed? Can anyone tell me what will be printed as output when I print x dot grad? So I have defined X as a 3 cross 2 matrix with all 1, and then Y is equal to X plus 5, and then Z is equal to Y square plus 1, and T dot sum, that is I summed everything, right? And then I did a backward pass, and I'm printing X dot grad. So what it will do is it differentiates T with respect to X. So I have a backward pass to T, right? It differentiates that with respect to X. So what will be the output? When you differentiate T with respect to X, what will be the output? Just think and tell me. Yes. What will be the output? If you want, I have given this, you just tell me. I am differentiating T with respect to X. So let me explain. Is there anything in the chat? Reference link, please. So here we will see how this T dot backward, what it has done, we will see. So here T, if I have given what print x dot grad, is it not? That's what I get. So if I'm giving print x dot grad, that is you are differentiating x with respect to T. So that is what is shown here, right? So what I need is I need to differentiate dt by dx, right? Why I'm giving partial derivative is I'm not taking the entire x, some values of x is taken, so that is dt by dx. So here summation I am representing t is equal to summation of I zi, where zi is equal to zi I have represented in terms of y and yi in terms of x. Now I need to differentiate t with respect to x. So I cannot directly go and differentiate with respect to x. So you can apply a back chain rule, right? So sorry, chain rule. You are applying chain rule. So what I am doing is dt with respect to dx, I am breaking this into t I am representing with respect to z, right? So dou z divided by dou x, right? Dou z divided by dou x. Again az I am representing in terms of what? Y. So dou z by dou y. So this I am representing like this, right? Dou z by dou y, and dou y differentiate with respect to dou x, where dou y I am differentiating with respect to x. So this is what is done. So for dt by dx, I am rewriting it as dou z by dou y into dou y by dou x. So now you differentiate dou y by x. So y when you differentiate with respect to x, when you differentiate this, what you will be getting? You will be getting for 5 it is 0 and for x it is 1. So you will be getting 1 for this particular term alone. And when you differentiate this, what you will be getting? You will be getting 2y here, 2y, and this 1 will be 0. So what I am getting is 2y into, that is here it is a dot product. So 2y into 1. 2y into 1 is nothing but it is equal to 2y. So you know what is y? Y is nothing but it is 6. So 2 into y, it is 12. So what I will be getting is I will be getting 12, right? So that is what this AutoGrad module does. right? So what is happening here is it is applying a chain rule, and you are now I have applied one function. I have defined one variable and defined a function with respect to that variable. Another function over that I am writing another function, and I am summing up, and then I am doing a backward pass, and what I am trying to do is I am trying to print the gradient. That is what I am doing. So this is how it calculates, right? Hope it's clear.
Yes.
So I'll go back. So far, any doubt?
No, ma'am. It's clear.
Yeah, thank you. So that is what is happening. So here it is printing. When I print x dot grad, what I'll be getting is I'll be getting all 12s. Tensor all 12. So here you can see nothing is book kept here, right? It is printing the gradient value, right? So that is the advantage of using torch. You can build relationship between the tensor, and you can easily do the back propagation, right? So the main function of deep neural network is training the neural network. For training, you will be first doing forward pass. Forward pass is nothing but from input layer, you will be calculating the activation function of the hidden layer, from hidden layer to next hidden layer. So till output you go, and once and the output layer, what you will check is whether your output is whatever output you are predicting that is equal to the actual. If it is not equal, then you will calculate the loss and you will try to back propagate. What you will do in back propagation is you will try to adjust the weights or and biases, right? Based on the loss, you will try to adjust the weight and bias. And once again, after completing the backward propagation, once again you do the forward propagation, and you will check whether you are able to achieve, whether your loss is reduced this time. If not, again back propagate. This is what is happens, right? So for that this tensor plays a major role, right? Just after applying multiple function, if I just give t dot backward, it performs the backward propagation, that is the differentiation, and you can print the gradient with respect to weight or with respect to bias, whatever it is that you can print. That is the advantage, right? So that's what I wanted to tell. And now we'll see how to calculate the loss function. So what I'm taking is I'm defining an x-axis a random vector. Here it is a single array vector, right? 20 variables, and it is having single column, 20 rows, right? And I'm defining the grade as true, right? Since I'm going to perform the gradient, I'm making this requires grad is equal to true, and here I'm making y is equal to 3x. This is my ground truth model. Ground truth model is nothing but I'm defining as some complex function y is equal to 3x minus 2, right? This is my model or function which I am defining. Now what I'm going to do, this one is I'm going to define a y hat. Y hat is nothing but this is the expected thing. So y hat, what I'm defining is w into x plus b, where w is kept initialized as 1 and b bias is initialized as 1. So actually this is my ground truth. Ground truth is 3x minus 2, but I am assuming that this is the predicted one, y hat. Y hat is the predicted one. Y hat I'm giving 1x plus b. So from 1x plus 1, this is 1x plus 1, I should define a neural network which learns and then which converges to the y, right? So starting from 1x plus 1, it should reach to 3x minus 2, right? That is my challenge, right? So what I will be doing is I will be initializing w and b, and then I'm calculating y hat. Y hat is nothing but w into b plus b. Sorry, w into x plus b. That is 1 into x. X is nothing but 20 random values plus b. Then I will be calculating the loss. Loss is nothing but here I'm just calculating the square loss. I'm not using. So I'm not using GPU. So it's asking me to change to runtime. Okay, so here you can see this is how loss. Loss is I'm calculating loss is nothing but y hat minus y and whole square. So I'm not calculating mean error, but I'm calculating the difference and squaring it. So why I'm squaring is to avoid the negative value. I'm squaring, and then all the weight, all the loss, I'm adding it, right? That is torch dot sum of all the weights, right? So this is how I'm calculating the loss. So once here I have defined the ground truth model, I have defined my own predicted model, and then I'm calculating the loss. Loss is nothing but predicted minus actual whole square, and then all the values sum. I'm going to print it as a single value. So all the, because it is a 20 cross 1, 20 cross 1, so the output will also be 20 cross 1. So all the 20 values I'm adding, and that I'm making as a single value, and then I'm printing. So when I print loss, I'll be getting like this. Right, this is the loss value 185 point something, and here you can see, since I have given requires grad is equal to true, here this is something, so it's giving a bookkeeping, right? So this is the loss it is printing, which is very high, right? This loss should be reduced. Initially the loss will be very high because here I need w should be equal to 3 and b should be equal to minus 2. I know this because we are only defining this. So but since because of that big variation, the loss is so very high. Now what I'm doing is I'm back propagating with respect to loss, right? So that is I'm differentiating the entire loss function with respect to w and bias. So if I'm a loss dot backward differentiates it, we don't know what happens internally it differentiates, and now I'm printing print w dot grad and b dot grad. So after differentiating, I'm printing w gradient and then b, that is this is nothing but differentiation of loss with respect to w, differentiation of loss with respect to bias, right? That is what I am printing. So when I print this value, I'll be getting some negative, since it is a random value, so it varies. So this is some negative value, this is a positive value, but it gives an intuition that we are going the correct way, because why here w dot grad is negative. Negative indicates that I need to train my w in such a way that the value of w should be increased. Negative indicates that I need to increase the value of w. So by just by seeing, you can know that here it is 1, it is 3. So I need to increase the value of w such that it reaches 3, right? So that is what is the indication here. So that this tells that w needs to be increased, and this tells that bias needs to be decreased, right? So when you take these two model, what happens is bias is -2, but we are defining it as +1. So this should be reduced, right? So the positive value tells that the loss should be it should be reduced so that it reaches the ground truth model, right? That is what this particular input defines, right? So whatever we saw here is just for a single iteration I am doing, right? I am doing it. So I am defining a simple model, and this is my own model which I am defining, and I am trying to converge to this particular model, right? So this is how the loss is calculated, and what need to be done is we need to update the weights, right? So that we are going to do it in a loop, right? So now this is for single entry we have done, so we need to converge, we need to make the loss to get reduced. So what it will do is we have to do that in a looping, right? So here I am defining a learning rate, and I am giving a very small learning rate of 0.01, and it can be 0.001 also. So here I'm taking 0.01, or it can be 0.5 also, depends on the application we can use. Here I'm using lesser learning rate 0.01, and I'm defining whatever the same thing, and I'm printing the value of w and b, and here I'm defining the same thing I'm writing here, but within the loop, right? Y hat is equal to w plus, that is 1 into x plus 1, and I'm calculating the loss, and I'm backward propagating. But after calculating the loss, I'm printing the gradient, but I'm not adjusting the weight. That is what I'm doing here in this loop, right? Within the loop, what I'm doing is with torch.nograd. What is torch.nograd? While taking autograd in the PPT, I told that The gradient is needed only till you make a forward pass and backward pass. Once you want to adjust the weight and bias, this W grad gives a difference. This bookkeeping is not needed. Just we have to have this value to alter the value of. So this should be used as any real number instead of a bookkeeped value. So this should be used as any real array. It should not be a tensor array, so it should be a real I mean without a bookkeeping, it should be an array, and that value has to be. So actually what I'm doing is I am adjusting the weight and bias based on the gradient value, right? After backward pass I will be getting W grad and B grad. W grad and B grad tells whether I need to increase the weight or decrease the weight, increase the bias or decrease the bias. That is what we saw here, right? So with that value, what we are going to do is we are going to adjust the weight. That is your learning algorithm does, right? So W is equal to W minus learning rate into W grad. B is equal to B minus learning rate into B grad, right? That is what. So without bookkeeping, I need to eliminate the gradient. So I'm eliminating it and I'm performing just this as a normal updation, matrix updation. It happens, and once it is done, again I need to remove the gradient. W gradient should be equal to 0, B grade should be equal to 0, right? And I am printing the values, right? So all happens within the loop, right? So we'll see how this code is executing. So I'm not executing because already I have executed and the output is here. So here the first two values, these 1.0, 1.0 is the initial value of W, and so after initializing I am printing. So that is what is printed here. And then each and every time after calculating after making the forward pass and backward pass and these weight adjustments, it's printing the weight, right? So you can see it started with 1, and here this became 1.3. Gradually it is increasing and coming to 3, and here this started with 1 and it gradually reduced and it is becoming -2, right? So this is how your learning algorithm tries to keep on update the weights, and you were able to update. Your network tries to converge. The neural network tries to converge. So this is this gradient and the loss dot backward. This helps us to do without much operation, right? So this is for a simple thing, and for a large loop, this is for 10, right? So here I'm using 1,000, right? 1,000 epochs, right? N is equal to 1,000. So number of inputs I'm taking 1,000 and epochs is 2,000. That is 2,000 times I'm iterating, right? So here I'm printing both the values as well as the time taken. So here if you see, it starts with 0.4 and here the bias is 1. When the learning algorithm runs, you can see how the value increases, because the first one is weight should go to, so it is 2,000 iterations, right? So you can have that many iterations here. I'm just scrolling down. So you can see from 0 it started and it's just update. From 1 to it's moving on. At one stage this becomes 3, and here simultaneously we watch the bias now it has become minus 0.4 something, and 1 point it has become 1, right? It should be -2, right? So you can see somewhere it is getting increased and decreased. There is some variation with the bias, right? Again it is becoming negative, you can see that, but you can see gradually your weight is increasing, right? So it's coming as 2's, the convergence is happening. So this shows that our neural network, we need to have multiple layers. Since we have only one layer here, it's giving this much. It's not converging. So here at one point you can see it is converging to 3, but here it is not an correct value. It should be -2, but we are getting -5, -4, -3 and all. So somewhere we are getting -2. So it's 2000 iteration. So that's why. So here you can see all the values. So at last we are getting -2, and this is that is 2.9. That is, it is converging nearly to 3, and this should be -2, but this is wrong. This is -4. So somewhere the bias updation has to be corrected. So we need to modify your neural network, right? That is what this tells, right? After this much convergence, we were not able to converge properly the bias. That has to be adjusted. And when you talk about the time, it takes the total time taken is 2.44 seconds, right? So the same thing again when we use for larger and then epochs. So when we execute, the time taken will be 5 minutes 27 millisecond for the same application with large number of inputs, right? When n is very large, then it is taking so much time. I'm not executing because it is taking time, so I have not executed this. So when you apply that is PyTorch when CUDA device, and the same code when you execute on the CUDA. So when you execute the GPU, what you can see in all the tensors, you have to define the device is equal to CUDA 0, right? And here, wherever you have the tensor, all the tensors you have to define explicitly, otherwise it will not be executed on the GPU. The same code. So it is taking 1 minute 46 seconds. So without I hope one of you asked me whether it is it is not varying, right? So big applications here you can see. So this takes 2.4 seconds, and the same. Sorry, this takes 5 minutes 27 seconds in your CPU. This is the same piece of code when you apply CUDA, it is taking 1 minute 46 seconds, right? So I will share this, you just execute and appreciate the difference, right? So that's all about the autograd function, loss function, other things. So if we have time, I can go through the feed forward neural network implementation also.
Ma'am,
How
how
to
did you know?
sigmoid and softmax function. Yes.
Yeah, how do we know what activation function has been used here, ma'am?
Here I'm using sigmoid activation function.
Okay, so if you want to change it, what parameters, where should we change it?
Actually, in this case, I'm not using any activation function. What I'm doing is I'm just defining. Actually, this is a very simple model. I have defined a model. I'm not defining anything much. Just I'm taking the sum, right? You can see this is the loss calculation. I am just taking the square sorry, different square loss, right? So this is a simple application where I'm not using any activation function here, right? This actually this is a building block for this. Only in the next example, I thought of showing you the activation function. Once again, I will just show you the example. You will be able to understand.
Okay, ma'am.
So I have used both sigmoid as well as softmax activation function. I will show that because of time. I took more time. I think slowly I went. I think I thought of covering that also. So all this I'm skipping. Just all our simple initialization. I'm just moving on to my model. Actually, this is the model. Is it visible? Once again, I'm not sharing, I think. One second. Sorry, I'm not sharing. Without sharing, I'm just talking. So actually here, this is the neural network I'm taking into consideration, right? Here, which this neural network has two inputs and two hidden layer 1 and hidden layer 2. In the hidden layer 1, I have two neurons. In the hidden layer 3, sorry, this is not hidden layer, in the output layer. I have only one hidden layer and one output layer. Output layer, I have 4 outputs, and then I have two hidden layer and two inputs, right? So two features I am giving as input, and this is multi-class classification. So four different classifications I'm going to have in the output, and this is the hidden layer, right? So here you can see A1, A2. A1, A2 is nothing but the summation, right? That is X1, W1 plus X2, W2 will be A1 along with bias, right? And then X2, X1, W3 and X2, W4 plus B2 will be A2, and then I will be applying sigmoid, that will be H2, right? And that output sigmoid function is given as input to this along with the weight I will be calculating. And here in the output layer, what function I'm using is I'm using softmax function. Why I'm using softmax here is, see, if it is a binary classification, I will be using sigmoid at the output. Since it is a multi-class classification, it is better to use softmax function at the output layer, right? That is what I'm going to use, right? So with this, I will be moving on to my collab file. So this is the model, whichever I have shown there, I'm taking this. So A1, please recall that. So we had two inputs, X1, X2, and hidden layer 1, we had H1, H2, and hidden layer 2, we had, sorry, output layer, we have four neurons, right? H1, H2, H3, H4, right? So what I'm going to do is, I'm going to call the hidden layer as H1, completely it as H1, and H2 is nothing but the activation function at the output layer, right? So it has it is nothing but 4 cross n cross 4 matrix, right? So here see, I'm that is A1 is nothing but it is the activation function which happens inside the hidden layer, right? Which happens inside the hidden layer. So A1 is equal to torch dot matrix multiplication of x dot weight. So x is input, I am multiplying it with weights of each, and then I am adding bias, right? So if my x is n, I am giving n different inputs, but that is, it is a n cross 2 matrix, right? Because it takes two features, so n cross 2, and then my bias is sorry dear. So x is n cross 2 and my weight is 2 cross 2 because it is having only two neurons, right? 2 cross 2. So when I multiply n cross 2 with 2 cross 2, what I will be getting is, I will be getting n cross 2 as the output, right? So this n cross 2 is given to the activation function in the hidden layer. So h1 is equal to a1 dot sigmoid. So I'm using sigmoid function for activation, right? And then I am applying that h1, that is, I will be having two h1 and h2, right? Two hidden layers, two hidden neurons, right? That I will be passing on to, that's what it is giving, n cross 2, right? Two hidden layers, two hidden outputs, that is passed on to the next, that is output layer. Again, I am performing multiplication with h1 comma weights plus bias. So this is the output of h1 is n cross 2 matrix. Weight is 2 cross 4 matrix, because from two hidden layer we have four outputs, right? So 2 cross 4. What I'll be getting is these two can cancel, and I'll be getting n cross 4. So n cross 4 will be my output. And now I am applying, this is called softmax, right? So what is softmax function? A2 dot exponential divided by A2 dot exponential sum, right? We have, I have shown in the presentation, it is nothing but x to the power of A2 divided by the summation of I is equal to 1 to n e to the power of 8 square, right? That is what we saw the softmax function. The same thing is happening. A2 dot exponential defined by A2 dot exponential dot sum. So it has to sum all the exponential values of the output, that is in the column wise, and then we are converting it into row wise, right? So AQIS will do. So I will explain what is this softmax function. I will be explaining and return H2, right? This is the model I am defining. Hope it's clear. So I am defining in the H1 hidden layer, I am defining sigmoid, and in the output layer I am using softmax function. right? So how this softmax function works, I will explain here. I have explained this with a sample example. Sorry, sample input. I will show that. See here, A is equal to random. Why this sum and why this unsqueeze? All these things I will explain here. So A is equal to some value and printing A dot exponential. It calculates the exponential value, and then I'm calculating the sum along the column. So I'm taking this. I'm cutting off this, and I'm sorry. I cannot run this. I need to run everything and show. 1 second. 1 second. So because of time, I'm not executing. So I'll take as such. So here what happens is it is defining. So print A dot exponential. The first output is the exponential of all the 2 cross 4 values, 2 rows and 4 columns, right? That is what is printed. And then what I'm doing is A dot exponential of sum of -1. So what it does is it calculates the column wise sum, right? So here print A, that is A dot exponential. First is A. This is exponential of A to the power, that is E to the power A, right? E to the power A is this one. And then what I'm doing is I'm calculating the column wise, right? That is this particular, I'm negating the column and I'm calculating. So all the first row is added together, and then here I'll be getting 9.6.12, and this column I'm adding, and then this. Excuse me. So what I'm getting is it is a one column, sorry, 2 columns, 1 row. But I need a column matrix. For that, I'm doing unsqueeze. So if I unsqueeze, I'll be converting this into column, right? So do you understand? So actually, I need to convert this 1 cross single row, 2 column single row, 2 column, 1 cross 2 matrix into 2 cross 1. That is 2 row, single column. So for that, I'm performing unsqueeze, right? So this is what is happen in the softmax function. The softmax function I have shown here as an example, right? So this is how, and here this is another example for that. And this is how I'm defining my sorry, where it is loss function. I have defined somewhere. Yeah, loss function I am defining here. This is the loss function. So loss I am defining is minus y hat of. So here what I'm using is I'm using cross entropy loss. Cross entropy loss I am defining, and then I am calculating accuracy. Accuracy, it's taking the maximum value of y hat with the dimension is equal to 1, and it is checking with y, and then it takes the mean value, right? So the maximum value is taken as the accuracy, right? So when you execute this code, you can see how your learning algorithm works, right? So if there is time, I will explain. Can I take 5 more minutes to explain this piece of code?
Yes, madam.
Yeah.
You continue.
Okay. So yeah. Sorry, because I have taken much time in the beginning. So here this is this is a simple one. I'm just a seed is defined, and here you are defining the weights, right? So weights, it is a 2 cross 2 matrix, because initial, you know that 2 inputs. So 2 inputs and 2 inputs and 2 hidden layer in the hidden layer. So that is why 2 cross 2 weights. And then I am defining the gradients also, and bias I am defining it's a 0, and then a gradient is true, right? And here this is weight 2 and bias 2 is for the output layer. Weight 2, bias 2, output layer, you can see it is a from input layer, from 2 neurons, it has to go to 4. So it is 2 cross 4, and we are setting the gradients, and then bias is this, right? So the learning rate is kept as 0.2 and epoch is 10,000. And here I am defining x train is equal to x train dot float, and y train, that is, these are all the training variables, right? Actually, I'm taking a data set. In the data set, 80% of the data or 75% of the data will be used as a training, and 25% of the data will be used for validation or testing. right? So I'm defining that training data set, right? So I'm defining x as float and y as long. Why I'm defining y as long is, if you take the accuracy, uh, here I'm using y to check, get the index, right? So index, I'm for indexing, sorry, here in this loss function, if you take, I'm using y for indexing. So if, for that, if you are going to use anything as index, it should be a integer value. That's why I'm defining it as a long, right? So that is what is done here. Extra train is this is defined float and this is defined long, and then I'm defining two arrays where to store the loss and accuracy value. For each and every iteration it stores the value, and here this is the epochs, and now we are going to model y train and x train and loss dot backward, and this is how it works, right? So loss, so it is calculating the loss and it is appending, right? And it is calculating the accuracy also, and it is appending in the array. And once everything is done, once backward pass is done, once you append the loss and accuracy, what you have to do is you have to adjust the weights. So with torch.no grade, we are updating the weights. So weight 1 is equal to weight 1 minus weights 1 dot grad into learning rate. That's so what we are using here is we are using gradient descent algorithm, and after making this, get this thing, and we are making the gradient value 0. So this, why this is very very important. If you are not giving torch dot grad with the no torch dot no grad, then what happens is your entire computation fails. You will not be able to converge because it keeps on bookkeeping the way keeps bookkeeping for weights and other things, right? So actually, okay. So that's what here it happens. Okay, so here after calculating the weights and bias, after calculating the loss, after getting the gradients of weight and bias, we are adjusting the new weights and bias for the next iteration. Once it is done, again you have to make the gradient value equal to 0, right? So this is done again and again, and after doing this, we are plotting the loss array, right? Whatever we have in the loss array and accuracy array, we are plotting it with red and blue, right? So your red shows the loss and then blue shows the accuracy, and we are plot dot show, right? And we are also printing the loss before training and loss. So array 0, loss array 0 has the before training value, after training value will be there in the last value. So that is why I'm giving -1, right? So when I execute this code, what it will do is it will show me the plot, and this plot tells that that the red is for loss, right? So it tells that the loss initially it was larger, and it started when you try to iterate, right? It tries to gradually reduce. Loss is reducing, and when you take accuracy, accuracy was initially it was around very low value, and once you started iterating, your accuracy started increase, right? At one point, both becomes a saturated value, right? So this is the loss before training, and loss after training. If you see, it is not converging to 0, but it is near to 0. So loss is somewhere near to 0. So this is how you will be training your network. Hope it's clear. So actually here what I have taken the data set, I have not spoke about the data set, thinking the time is not there. So here what data set is used for this is the data set we used. So here make blobs. So it is in SK learn. So that is used where the samples taken is 1000 and 4 centers. So the output has 4 different classification, and that is the 4 different classification we are going to see. And it takes 2 features, and here what is given is random state is equal to, so we have make the random state is equal to 2, right? So why this random state is made? So whatever everybody should use the same type of thing, right? And then I'm trying to print after defining that, what I'm trying to do is I'm trying to print, actually here I'm storing data and labels. Data is 1000 the values with 4 different classification and 2 features, right? And labels is initialized with. So I'm checking the data dot shape and labels dot shape. So data is 1000 with 2, and then the labels. So we have 4 different classification, and for 1000 input value, we have 1000 different labels. That is what is the data. That's all about that's about the data set. And then when I try to plot this data set, I told it has 4 different classification. So I have given a red and a green. So whichever is nearest to red, that is given in orange. Whichever is nearest to green, that is given in this particular color. So here, this tells that what is my X train and X val. X val is nothing but your testing data. So X train is training data, X val is validation data or testing data, Y train, Y val. So how I am defining is I'm splitting the entire data, the 1000 values, into some for training and some for testing. So when I print the shape of testing and then validation, what it is giving is 750 with 2 input features. This is given as taken as the training set, and 250 this is validation. So the 1000 data is divided into 2 halves. One is for training and this is for testing or validation, and the shape of label is 1000, right? So this is how we will be this is how so actually, and then this is the model which we are using, that is your neural network model is this one. And the loss function, accuracy, everything we saw, and we saw how it is calculated, right? Actually here you are writing your own code, but when you use you can also use nn dot functional, right? When you use nn dot functional, the automatically you can define, right? So all these you will not see any change. So all these are same. So I hear what I'm using is I'm using, previously I used a mean square loss. Here I'm using cross entropy loss. So you can use see here f is f I'm defining as nn dot functional as f, right? So I'm using the functionality which is predefined in the Python. So I'm using I'm not defining the loss. I'm just directly I'm telling that f dot loss entropy, right? Only that change I'm doing, and I'm again executing. So you can see the difference. Again, this shows the loss, and then this is the accuracy is increasing, loss is different. So we have a slight change, right? The more or less both are same, right? The before loss after training is 0.9 something there, and here also the same, right? So now we'll see how to use nn dot parameters. So this is a very good features available in Python or tensor PyTorch. So here import torch dot nn as nn. So I'm defining nn as nn itself here, and here this is the I'm defining the class. First network is a name given to that class and which belongs to nn dot module, and I'm defining the init function and the self init, and then I'm initializing a super of init. Super of init is nothing but the first network class I'm initializing, and here I am making self dot weights. So I'm defining that's weights, weight 1, bias 1, weight 2, bias 2, all these 4 parameters as nn dot parameter. So I'm defining that as a nn. So I'm not here, see why I'm doing this is once I initialized all the parameters which need to be modified as nn dot parameter, I need not change the weights or bias each and every time, right? That is, we'll see how it is happening. And then this is your now there is a slight modification in your model. So a1 is equal to torch dot mult x dot self weights. So weight, automatically the weights value gets increased or decreased. So here self weights plus self dot bias 1. So whatever value I'm using here, the same thing I'm defining. H1 is equal to this one, A2 again self weight, wherever weights and bias are used, I am using self dot weight, self dot bias, and then here this is H1 is sigmoid and H2 is softmax activation function I am using, right? And I am defining the fit, right? So here this fit function, it is again a do loop where it executes for 1000 epochs, and the learning rate I am defining is as 1. You can change the learning rate and you can play with this code and you can see how this is working. And I'm bookkeeping the accuracy and I mean these two initializing the arrays, accuracy and loss array, and for each epoch in the range, what I'm doing is I'm calculating y hat. Y hat is nothing but function of x train. So here I'm calling the function with the training value, and then I'm calculating loss by using cross entropy, and then I'm calculating the loss and then accuracy by using loss function and accuracy function, and then backward propagating. And with torch.nograd, see, I'm not changing any value. Just I'm giving for param in fn dot parameters, param is equal to minus learning rate into param dot grade. See here, if you see the previous function where I need to define all these things, right? I need to define weight 1, bias 1, weight 2, bias 2, all these things I need to redefine. But here, since I'm defining that as a parameter, right? So that as all the weights I have defined as a single parameter, just here in this, I am just giving with grade torch dot no grad for param in fn dot parameter, just I am adjusting the respective parameters will get adjusted, right? I not mention weight, separate weight 1, weight 2, bias 1, bias 2 separately, automatically. So whatever I'm defining there, so here the fit function will not bother, right, what to be modified. That is taken care by the nn dot parameter itself, right? And just I'm giving fn dot 0 grad, right? And I'm plotting all these things. So that is the advantage of using these libraries, right? So actually why I given this to make you understand, I have given how this loss, how this accuracy and other things are defined, but everything you can define as a built-in function itself, right? So if you execute, I'll be getting like, right? So next is NN lean loss function. So how to use it? So I will be using linear. So instead of defining separately the weight and bias, here I have defined. So here you can see self dot weight, self dot bias, weight, everything. So since it is a linear, NN dot linear, neural network dot linear I'm using. So what I'm doing is I'm just self one. So here NN dot linear of 2 cross 2, that is input layer. It has 2 neurons in the input layer, and the next one is 2 inputs and 2 hidden layer. And this is 2 hidden layer and 4 output layer, right? Just I'm simply defining that as a linear this one, and then I'm defining the forward pass A1 dot self dot linear of x, A1 dot sigma. See, even my function as defined very simple, right? I'm not defining weight, I'm not multiplying weight with the input, and I'm not adding bias. Just I'm giving A1 is equal to self dot L in 1 of x, right? Just I'm defining that my, so my model has become very simple and easy to understand. And then I'm calling this one, and that is to define the network. And then I can also import optim. This is to optimize your output. So how to optimize is I'm using SGD. SGD is nothing but stochastic gradient descent, that is applied on the parameters along with the learning rate. So automatically the parameters and then learning rate value will get modified by using gradient descent, right? So here again the loss is cross entropy loss, and we can use this y hat and white. So loss, and you are optimizing the step and optimizing the 0 grad. And now when you plot, you will be getting the plot like this, the same thing with a light modification, right? So this is how you can gradually build. So we have all the built-in function. So I have started this feed-forward neural network by defining my own network, my own model, by building the model, by building the loss and accuracy function. Then gradually I started using the inbuilt function, NN functionality, NN parameters, and then NN optim linear, right? So I will share this, you just to go through. With this, I stop here, and any doubts you can ask me. Hope I have did some justification.
Yes, madam.
Yes, ma'am. It was fantastic, really. Excellent, ma'am. Very interactive and really practical.
Okay, thank you. Just I have some more thing to share with you. So many people have the confusion whether to work on PyTorch or to work on mm, uh, uh, once again, whether to you go in for tensor flow, right? So TensorFlow or PyTorch, which is best? That is many people doubt. Sorry. So I just wanted to give the difference between, is my screen is visible? Okay, it's visible. Just I want to give you the difference between frameworks, that is PyTorch and TensorFlow. So when you take PyTorch, it has totally Python support, because I told the entire coding, entire PyTorch application is built on Python. So it is easy to use all the APIs, and it is fast and feels and native, and it is designed by Facebook, and it is dynamic, and you have the CUDA support also. And when you talk about TensorFlow is also a very, very famous framework. Actually, initially, people found it very difficult to adapt to TensorFlow, but because of a lot of research and other things, now the TensorFlow itself is made, because it is a product of Google. So the TensorFlow itself is made very user-friendly. And one of the fantastic thing about TensorFlow is its visualization. You have a very good visualization facility in TensorFlow, right? So that is visualizer is one of the major thing, and then easily trainable. You can easily train by using TensorFlow. That is, as I told earlier, initially it was tough. Nowadays it is very easy, and you have layered components. So you have different layers, and it is easy for you to understand and grasp, and very flexible. And even though it was designed initially by Google, and it is owned by Google, and it is now open source, and that's this thing about TensorFlow. Now we'll see what is the conclusion, which to use, whether to use PyTorch or whether to use TensorFlow, right? If you have that doubt, so when you take PyTorch and TensorFlow, this is both are good, equally good, 50%, 50% for both, right? So where you can use PyTorch is better for rapid prototyping. That is, when you start your research from the scratch, and when you are building the components there, PyTorch is very, very good. So you can use PyTorch, and PyTorch goes well with Collab. So you need not install anything in your laptop. Online itself you can do all the things, right? That is one thing. And this is a good start for hobbyist and small scale project. PyTorch is good, and you have better utilization and optimization by using GPUs. That is the major advantage of PyTorch. But when you talk about TensorFlow is very good for large deployment, right? When you have a very large deployment, it is good, and it is good for cross platform, right? And embedded deployment, right? It seems to be very good for this cross platform implementation and embedded department. That is, for example, if you want to combine IoT and analytics, and you want to apply the machine learning there, then this TensorFlow goes all very well. And this has a very good community base. So lot of researchers are using TensorFlow compared to PyTorch and you have many users for that, right? So that is the major advantage of using TensorFlow. But in my opinion, since I'm very comfortable with PyTorch, so I give 65% for PyTorch and 35% for TensorFlow. This is my opinion. Okay, so thank you. If you have any doubts, you can ask me now.
Ma'am, in the same way, can we construct SVM networks as well?
Yeah, anything you can construct.
Okay, for that also the built-in functions are available.
Yes, yes, yes. You just search. Actually, you see now we have the facility because of Python and all the libraries. You know, you need. Actually, I want you to understand. That's why I started from the scratch, right? I told you have many built-in. So if you just go through like SQL and other things, you have everything built in. All the libraries like your SVM, not only SVM, random forest, whatever learning algorithm you want to apply, everything is built in. You need to, what you need to do is you need to plug and play. What is the major challenge here is if you take a complex application, your challenge is which type of network I have to select, whether and how many layers it should have, how many neurons. That is the challenge. But apart from that, all the other things are already available, right? Already available. If you go through this sklearn data set and this one, it is having this skit. This is having all the libraries built in. You need to plug and play. That's it. This sklearn, no, it has all the libraries, right? So just you have to plug and play. That's it.
Okay, as you said,
So
only
you just yeah, yes.
yes, ma'am. Go ahead.
Yeah, that's what. So initially maybe the researchers may be feeling it difficult because of open source and other things. Now you are keep on building the library, right? So you give your library, and because and you have many things in GitHub and Kaggle. You can use Kaggle for the data set, right? So you cannot tell that I don't have this particular data set for my application. I don't know how to proceed my research and other things, because whatever under the sky, everything is available in Kaggle, GitHub, and all these libraries. Only thing, we need patience. We have to spend time. We have to Google search and then do, right? That is the only thing.
Yes, ma'am.
Yes. Is any more question?
Yes, participant, if you have any questions, you can unmute yourself and ask the question.
Actually, research is nothing. You have to sit, break your head, and keep your hands dirty, because we are all using laptop. There is no way to keep our hand dirty. But what I'm telling is, you have to sit, break your head, do some coding. Definitely, if you start, you will be getting a lot of features. You will be having a lot of errors. You don't know how to correct. No one will be there to correct. But because of the communities, right? We have a lot of communities available who are working on a particular problem. So you can join that community. You can share your problems, and you can get it rectified. So all these facilities are available now. So it is easy for you to do research, right? So
Very excellent session, madam.
thank you, Chaya ji.
Very chat box is full with feedback. Excellent
Oh, very
session.
nice. Thank you for that. But I too felt very good sharing my knowledge with all the people here.
Yes.
So thanks for the opportunity, ma'am. Because of you only I got this opportunity. Thank you. And I take this time to thank the management of your institution, as well as the head of CSE department and other coordinators of this program. And all the best, ma'am, because you have 3 more schedules to run, and it is very, very hectic
Yes.
task, because
Yes.
5 days is okay, but 10 days
Yes, sir.
FDP is a ridiculous task. So all the best. Thank you.
Thank you. Madam, sir, Prabodh sir.
Yes, ma'am.
Please.
Yes, ma'am. It's my privilege to propose a vote of thanks. I am session coordinator behalf of Department of Computer Engineering. Thanks to you for sparing your time for this very informative session. I hope all participants learned a lot. That you cover all the things like continuous function, need for complex function, single layer neural network, then how to build complex function with DNN, then terminologies in of DNN, then gradient descent algorithm, and in the afternoon session, hands-on session on the NumPy on the Jupyter using NumPy and AutoGrade module. It was fantastic. So thank you, madam, and thank you all participants for making this session successful and interactive by your contribution. So hereby I declare this session is over. Once again, thank you very much, ma'am, for your knowledge. And you can see all the participants are very happy. So they are appreciating your session. It was very informative.
Okay. Thank you. Thanks a lot, sir. Thank you.
Madam. Tomorrow's session will be at 10 o'clock. All the participants.
Thank you so much, ma'am.